Hi, Assalamualaikum and a very good morning. So welcome to CHEMBLAST session for the year of 2024 and 2025 for the chemistry subject SK015. So for today's session, we're going to tackle chapter 4 chemical bonding, and we're going to look into question 1a and question 1b respectively. So for question 1a, the proton number of element X and Y is 12 and 7 respectively. So we have to show the formation of the compound form between X and Y using Lewis symbol. So here are the tips. So first, we need to write the electronic configuration for X and Y to determine the number of valence electron. So the proton number of X is 12. Therefore, the electron of X is 12. And similarly goes to Y. It has 7 proton, which is at neutral state. The electron that Y has is 7. So we need to write the electronic configuration first. So for X, since it has 12 electrons, therefore the electronic configuration is 1s2, 2s2, 2p6 and 3s2, which is total up going up to be 12. So it has 2 valence electrons, which is referring to group 2, which is a metal element. Meanwhile for Y, it gonna has an electronic configuration of 1s2, 2s2 and 2p3. So it has 5 valence electron, which refers to group 15, which is a non-metal. And since you know that X has a 2 positive charge, meanwhile Y has a 3 minus charge, so therefore if we were to cross it over, you're gonna get X3 and Y2. And the next step is we need to draw the Lewis symbol for X and Y. So we have 3 X here, so we need to draw it 3 times. X, X, as well as X. And X will have 2 valence electron. 1 dot, 2 dot, 1 dot, 2 dot, 1 dot, 2 dot. Meanwhile, for Y has 5 valence electron. So we need to draw Y 2 times. So Y and Y. 1, 2, 3, 4, and then 5. 1, 2, 3, 4, and then 5. Okay? And then what you need to do is you need to show the formation of the compound, whether by transferring of electrons if it forms ionic compound, or you need to draw the sharing of electron if it is a covalent molecule. So from here, you know that it is an interaction between metal and non-metal. So metal and non-metal is basically an ionic compound. So they're going to be a transferring of electron. So when there is a transferring of electron, you need to draw the arrow. So this is what you need to do. So you need to show the arrow transferring one electron to here and the other electron to there. At the same time, this arrow here will transfer to the Y here in order to get octet, because it has 5 valence electron. So when you transfer 3 electron, it will become 8 valence electron, which is octet. And 1 here and 2 here will give up to another Y, so that it also become octet. So there need to be a transferring of electron. Okay, so when there is a transferring of electron, the product form, since the electron of X is being transferred, so there's no more electron here. So Y, at first it had 5, now it become 8. So you need to draw 1, 2, 3, 4, 5, 6, 7, 8 electron at Y. So this is how you draw the formation of compound between X and Y via ionic compound. Next, for question 1b. So for question 1b, we need to draw the Lewis structure of PCl5. The tips here is simple. First, you need to count the total number of electrons from the number of valence electron of P and chlorine, which is phosphorus and chlorine. So phosphorus will have 15 electrons. So you know that the electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p3, which is it have 5 valence electrons. Meanwhile, for chlorine, it's gonna have 17 electrons. So you're gonna have 1s2, 2s2, 2p6, 3s2, and 3p5, which is 7 valence electrons. Therefore, you need to count the total number of electrons. So phosphorus, we have 5 valence electrons, and for chlorine, basically 5 multiplied by 7 valence electrons here. So you're going to have 35. So the total number of valence electrons will be 40. And from here, you need to draw the Lewis structure. Okay, so phosphorus is going to be the center, which is the more positive charge, and then it has 40 electrons. Therefore, it's going to branch with 5 Cl. So 1, 2, 3, 4, 5. Cl, 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 Cl here. One bond consisting of 2 electrons. So 1, 2, 3, 4, 5. So basically minus 2 times 5, which is 10 electrons. So 40 minus 10, you will left with 10 electrons. So the 30 electron here will be used in order to complete the octet. So you have 2 electrons here. So 1, 2, 3, 4, 5, 6 electrons will be used up at the terminal atom. So you're going to repeat that 5 times. Okay, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6. So minus 30, and then all the electrons will be used up. So this is how you draw the Lewis structure of PCl5. The next question, you need to state the type of exception to the octet rule exists in PCl5. So from here, you need to focus on the central atom. So it have 2, 4, 6, 8, 10 electrons at the center. Okay, so when it has 10 electrons at the center, it means that it is more than 8. So if it is more than 8, then it is known as expanded octet, because phosphorus will have more than 8 electrons at the central atom. And then for question 3, we need to determine the electron pair geometry and molecular geometry of PCl5. So from here, we need to determine the number of bonding pair and lone pair for phosphorus. So you only need to focus at the middle. So from here, you can calculate the number of bonding pair. So we have 1, 2, 3, 4, 5. The bonding pair is the single line here. Is there any lone pair on phosphorus? Nope, there's no lone pair at the phosphorus. Therefore, the total electron pair gonna be 5 plus 0. So 5 plus 0 gonna be 5. And hence, the electron pair geometry, when it is 5, which is AB5, will be trigonal bipyramidal. And at the same time, since it is AB5 without any lone pair, therefore the molecular geometry is going to be trigonal bipyramidal as well. For the next question, we need to determine the type of hybridization for phosphorus in PCl5. So first thing first, you need to determine the total electron pair for phosphorus. So you can use the information from the previous question, and we need to predict the type of hybridization. So from previous question, you know that the total electron pair is 5, because bonding pair is 1, 2, 3, 4, 5, and there's no lone pair. So we have 5 electron pair here. So when we have 5 electron pair, then our answer going to be sp3d. If we have 2 electron pair, it's going to be sp. If we have 3, it's going to be sp2. If we have 4, it's going to be sp3. If we have 5, which is in this case here, we're going to have sp3d. If you have 6, we're going to have sp3d2. Okay, so the answer here going to be sp3d hybridized at phosphorus. Okay, and for our last question, which is V, we need to predict the polarity of PCl5. So from here, what you need to do is you need to check if the dipole moment can cancel out each other or not. Okay, so the usual tip that is given, if there is no lone pair, usually the molecule is non-polar. So what you can do is you can check it, because you know that PCl5 will have the electronegativity of Cl is stronger than phosphorus. Therefore, the bond dipole will move towards Cl, upwards and downwards. Okay, so it's gonna cancel out each other. Okay. And then on the right hand side here, we're gonna go upwards and downwards here. So it's gonna create a resultant at the center. So right hand side and left hand side will cancel out as well. Therefore, dipole moment of the bond will cancel each other. Therefore, mu is equal to 0. So when mu is equal to 0, PCl5 is a non-polar molecule. So it's stimulating as what you can visualize here. Upwards, downwards, will create something at the left hand side, cancel out with the right hand side. So it's going to be 0. Upwards and downwards, so it's going to be 0. That is why PCl5 is a non-polar molecule. Alright, so I think that's all for today's session. Thank you for your attention and goodbye. See you later.